Hello, everyone. We're going to continue our discussion about the analytical function, Windows analytical function within the SQL Server and Azure SQL environment, because they are very powerful tool that you can use to build some really advanced analytics. If you don't want to go towards the big data, and if you want to generate the best outcome within the structured data, so you need to have a very good grip on the Windows analytical function. And that's why, if you remember, I showed you last time that Microsoft even published a full volume on this topic, just to show the importance of using the Windows function. So a quick recap: we have discussed the four types of Windows function within the SQL. In the last video, we discussed the ranking function, where we can rank the values, and these ranking can really help us in different scenario, to tag the rows with unique number. And if we see that there are duplication in our record, and we want to keep the duplication, but obviously we want to uniquely identify the row, so we can use the ranking function. We can assign the unique row number, and we have seen in the last video. I'm just going to put the link in the description for a reference if you just want to understand the analytical function and see the ranking function in action. What we're going to do today, we're going to discuss the ranking function with the partition. Now, what we can do, we can apply the ranking function on a full table, or we can slice the table and then apply the ranking function. So it's more like, you divide your block table into chunks, and then in each chunk you apply the ranking function separately. And afterward, we're going to see the Windows aggregates as a next topic. So let's move on. So these are the ranking function. Let's first go to dev environment. We'll see how the partition work, and then we'll come and see the Windows aggregate function. So let me reshare my screen, and I'm going to share my dev environment. All right. So like you can see, we are already using the same table, and let me just, for a review, I'm going to show you the schema. We have employee table, where we have some attributes of the employee, and we have the organizational level and job title. So obviously, organizational level shows the organization structure from top to bottom, and obviously within the each level we have different title, and we are organizing our employees based on the organizational hierarchy. And obviously we have a bunch of other columns, which include marital status and gender, hire date, salary flag, vacation hours, and the sick leave hours, beside other additional system columns. Now, coming back to our topic today, we are going to, so last time what we did, we just, provide the row number, and then we just mention the order by class, and it apply the row number, which obviously assigning a unique ID on the full table, without partitioning, or without dividing the table into small chunks, right? So what we're gonna do today, we're gonna do the division first. Like, we're gonna split the table into small chunks, and how we can do it, that's the topic. And then we apply the ranking function. So we have the partition by clause, and whatever column we mention, SQL will divide the table based on the value of that column, and then apply the ranking function. So for example, in this case, if I'm using the organizational level, so the whole table is going to be divided by the unique value of organization, and each value gonna have the rank accordingly, or if each value is going to have the ranking function accordingly. I just use rank because rank is already a function, so I don't want to confuse you. So whatever function from the ranking side you're going to apply, regardless, it's going to be row number, it's going to be rank, dense rank, on entire, based on the value of that column which we are using in the partition by clause. The table is going to be split, and then each block is going to have its own ranking. Now, NF theory, let's see it in action. So syntax is pretty similar. The only difference in the over clause, we just mentioned the partition by clause, and then we mentioned the column name. So column name, whatever column name we're going to use it, that column name is going to use to partition the table. And obviously you can specify the order by clause to, if you want to sort the rows during the ranking based on a particular order. All right, so if I run it, so we'll see how it actually partition our table. It's going to partition by organizational level. So you can see the null is coming first, because within Microsoft, the default behavior is it always bring null as first before any other column. So we only have one. So you can see the row number has assigned to this null organizational level as one, right? Now, like I mentioned, the value, the ranking is going to be reapplied as soon as the new value of the organization comes into the picture. So you can see now we have value 1. So ranking has been reset, and now we are starting applying the ranking based on the next organizational level. And you can see the ranking row number is starting from 1 all the way, and then how it is applying based on the job title. The ordering is based on the job title. So that's how you can actually control the sequencing of the application of the analytical function. So obviously the title which is high, that title is going to get the lowest rank. And because it's we are applying it in the ascending order. So you can even reverse it if you want to do it. Just take out the descending clause, or maybe it's a good exercise for you to think how you can actually reverse it if you want to, right? But the point is, now you can see with the new organizational level, which is 1, the ranking is starting again all the way 1 to 6, I do believe. Yeah. And as soon as 1 has been finished and we are getting organizational level 2, you can see again the ranking function or the row number sequence has been resetted, and now we are starting again for all the way to applying the row number for organizational level 2 up to account manager. So we have almost 27 title in the organizational level 2, and you can see they have been arranged. Obviously, by job title means they are arranged in the descending order in the alphabet. That's not the logical order that has been aligned with the organizational hierarchy, right? So if we want to do it, there are additional technique that we need to apply to do these sort of, to control this sort of hierarchy, right? So that's how we actually partition our ranking function, and that's the concept of partition. Very, very powerful and useful. You're going to actually see in your day-to-day business requirement. And these functions are highly optimized and strongly recommend to use. Instead of building your lengthy script, if you can use the ranking function to reduce the code, obviously it's going to be efficient to execute once it's being submitted to database query engine. All right, so that's all about the ranking function. And now we'll come back to our next category, which is Windows Aggregate. So let me just go back to our slides. So Windows Aggregate, now what we are going to do, so we are going to, like you can see from the name, now we are going to apply the aggregation on the table level. And obviously the same way we can apply the aggregation on the full table, and we can apply it on the chunks of the table. The why we call it window aggregation, so you don't need to group the whole you don't need to group the aggregation by column, which is obviously a limitation in the pure aggregation function. Like any column that has been used in the aggregation, if you want to add an additional column, it has to be part of the group by clause. Otherwise, it cannot come into the query, which is not a requirement in the window function. Like for example, in the sum function, if I'm actually using, for example, vacation hour into my sum function, and I want to display it with the marital status, In the group by, we have to mention the group by in the group by clause, because that is going to be used to define the sum. However, if we want to just use it independently, we don't want to we don't want the impact of marital status on the total sum, so we use the Windows function. I'm going to show you shortly into the demo. Right, so these are the Windows aggregate function that we can use as part of the Windows analytical function. Very, very powerful again. So now we are moving from ranking. Ranking is more like, sequencing, controlling, and dividing our table into chunks, so we can, use that output for further processing. But aggregation is more like applying the same aggregate function that you have learned into previous video. But what we're gonna see as a difference in here, these aggregation are independent of the grouping of the column that you can associate with the final output in the final result. So hopefully that makes sense. We're gonna now jump into our demo again. Let me go back into my dev environment. All right, so that's going to be, so we keep our partition by organization level column as it is, just for a reference, right? But now what we are going to do, we are going to apply the count star, and we are going to apply on a full table. We are not going to specify any column, and we'll see how it actually return the information to us. Like you can see from the column I mentioned, the total record, which hopefully gonna show you that's gonna return the total number of rows in the table. So let me run it. So we can see, so now you can see the total number of records are coming as part of each row. In the if you use the aggregate function, so here you're going to see the difference between Windows function and the aggregate function. If you use the aggregate function, you have to do a lot of additional step to merge these outputs together, because obviously if you are counting it and you want to if you are counting the rows of the table using aggregate function, and you want to attach the additional column which is not part of the aggregation, you have to do a lot of additional or indirect step. But with analytical function, the beauty is you can just work independently on both sides, the aggregation and the simple column, and at the end they can be merged together to display as a outcome. All right, so we have the total number of the count star over without any column. Like we have seen, it is returning the total number of rows in our table. So let me quickly show you the total number of rows just for confirmation. We have 290 records. Look, you can see in here at the right bottom. Coming back to our video on, sorry, our topic on aggregate, we were in here. All right, so we have already applied it. Now what we are going to do, we are now going to partition our count, obviously by the organizational level. So again, the concept is the same. Now it's going to partition by the value of the column that we are mentioning in the partition by clause, and then it apply the aggregate function. So you just need to remember the core concept, and everything will make sense to you. So what's going to happen, so now I'm using, instead of any ranking function, I'm using the aggregate function. So the sequence will still remain same. It first chunk the table into small chunks based on the value of the partition by a column, and then for each value of that partition by column, each chunk of that table, it apply the aggregate function separately. Now we'll see it in the action. So again, we are using the organizational level column, and we are, instead of doing the allocating a unique ID, what we are going to do, we are going to count the total number of rows within that block or chunk that has been allocated based on the organizational level. So let's see. All right. So in the first one, like you can see for the null organizational level, we only have one record. So it counted it as one. Now you can see we have the next one. We have vice president of sale. Because what I did, I'm actually using the organizational level, but then I'm actually ordering by the job title. So you can see it is coming in that order, right? So you can see the number is adding in a sequential order. So for example, the first record we have one, and then we have two, because it is accounting based on the job title. Let me make it simple, because then I think we can understand it in a better way. Let me first show you the outcome without the job title, because that would be much easier. Because now we can see the table is only going to be split by the organizational level, and then the aggregation function has been applied on each block. All right, that's much better. Now you can see we have the first value of the organizational level, which is null, and we only have one record. So the sum is coming as 1. Now the second chunk has been created based on the organizational level 1, and you can count. We have 6 record, 1, 2, 3, 4, 5, 6. So the total count is going to be 6. Now, as soon as we get the new level in the organization, we're going to have a new count, and that is based on the next organization level, which is in this case it's 2. So for 2, we have 27 records, so that's where the count is 1. So now you can see that's how we apply the sum function. Sorry, how we can apply the aggregate function using the window function. Now you can calculate some really great matrices, like if you want to see, okay, what's the percentage of each organizational level to the total number of employees within the organization, because obviously every level is defining the number of employees on that level. So what we can do, we are going to divide it. We are going to divide it percentage of level, which is indirectly showing us that, okay, what percentage we have at each level, which is reflecting the number of employees, that, okay, what percentage each level is retaining from the employer perspective into our organization. All right, we have a bunch of errors that we're gonna fix by putting the comma, because comma was the culprit. And now we are good. Let's run it. All right, you can see we have all the way 0, which is not very promising, because for somehow it shouldn't come as 0. We are expecting some values. So let me show you where the error is, because the value is numeric without any decimal point. So once it's used that value to divide another numerical value, it treats the result as a numerical value without precision. However, in this case, we need the precision, because without that, we are not going to get the actual result, right? So what we're gonna do, we're gonna cast them into correct data type, so we can get the right result. As float, and I'm going to cast is as float, right? So now we'll see whether it's going to fix our query or not. Yeah, we are getting some good result. Like you can see that what's the percentage of each level is to the total number of what's the percentage of employee on each level is the total number of employee, right? A very good metrics that metric that we can use to report to the executive or the board. And last thing, like you can see, it is coming into 0.222. Like if you want to present it into a proper figure, what we can do as a last step, once the whole calculation has been completed, we are going to multiply it by 100, and then we are going to round it by 2 decimal places, right? So now let's run it again. And now you can see we have a very nice representation. Okay, 2.07%, 0.34%, 9.31%. And if you calculate the total sum of all these unique level, it is going to be equal to 100%. So what I'm going to do, just show you how we can prove it before I conclude as a bonus item. I just want to make sure that my total value is coming, especially that new column that I have created, percentage of level. I'm going to do, I just want to display the sum of distinct percentage of level. Let me show it to you. So you can see the whole the contribution of each level is equal to the is equal to the 100%, right? So that's just as a surety that our calculation is correct. Like we are not going above 100%. So hopefully it will make sense and it will help you to get a command on the Windows aggregation function and the ranking function. Very powerful concept. Try as much as you can, because that will really help you to build some very powerful script in your actual job once you get the real business requirement. And thanks for watching. If you have any question, please put in the comments. More than happy. Like the video. I'm gonna see you in the next video where we're gonna discuss the analytical function.